Welcome to RFVision-1 demonstration. RFVision-1 is a wideband scanning transceiver which allows signal activity detection, real-time recording, and RF playback. RFVision-1 covers up to 6 GHz. We have another product called RFVision-2 which covers up to 26.5 GHz. Together, these two products are DTA's offering for spectrum intelligence application. RFVision-1 is actually composed of two components. One is the DTA3290 software radio receiver. The other is DTA1000 server rate system. This system has up to 8 terabytes of storage, and the data flow between the two systems is over the 10 gigabit network. There is a separate 1 gigabit for control. Now here's a quick block diagram of the 3290 system. The RF signal is input to a RF down converter, digitized by an ADC. The RF signal is digitized by an ADC. It goes to a DDC. The baseband complex IQ data is put on a 10 gigabit network, which goes to the server. Similarly, the output from the server through the 10 gigabit network goes to a dual interpolating DAC with built-in up converter onto the RF up converter. So the RF input and output are independently programmed by a synthesizer. The RFVision-1 system is typically shipped in a shock-protected enclosure, which you can see here, and there are the 3290 receiver and the 1000 server. They occupy 2U rack space. And here are the important features of the RFVision-1: 20 MHz to 6 GHz frequency coverage, separate down converter and up converter for independent tuning of the receive and transmit channel, 40 MHz instantaneous bandwidth, 16-bit ADC, 16-bit DAC. There's a large Vertex 5 FPGA which has a built-in DDC core for bandwidth selection, a 10 gigabit network to carry full bandwidth data to the computer, a separate control for 1 gigabit control network. The real-time recording of the full 40 megahertz bandwidth can happen for over 11 hours. We supply a simple SIG Inspector GUI software with the RFVision-1 system. This allows you to scan the spectrum, select activity, look at an FFT, and record that activity. You can optionally be supplied with SDK and API for user development. Here is a little screenshot for the SIG Inspector control GUI. This GUI from a user laptop allows you to scan the spectrum, do a wideband 40 megahertz energy detect, and you can see it in the waterfall display here. The energy is color coded, so higher the energy, more red it is. And there's a waterfall display covering 20 megahertz to 6 gigahertz. Once you select an activity, you see the corresponding FFT, full 40 megahertz bandwidth. This is the occupancy chart, which all the energy that have been detected across the entire spectrum. And what you're seeing here at the bottom is a signal power display of the current scan and the maximum value of all previous scan. We'll now show you a little demonstration of the RFVision-1 system. Here is the RFVision-1 system. This is the 3290 software radio, and this one is the server. As you can see, they occupy 2U rack space. This is not mounted in a shock mounted rack. What we have done here for this demonstration, we have connected a little antenna, that's the RF input port. Here is the IF output, and the IF output is connected to the ADC input, and so the data is digitized, goes to a digital down converter, and through the back where there is a 10 gigabit network comes to the server where the IQ baseband data is being recorded for full 40 megahertz input. The configuration screen for the SIG Inspector control GUI. This is where you set the sampling clock, you select any trigger source, you also select the RF attenuators, and also the DDC decimation. And once all the all the parameters are input, you press the start button, as you will see it here, and the system is programmed. And this is the next screen, which shows you the waterfall display on your left. This is a waterfall display for the entire scan from 20 megahertz to 6 gigahertz. And on the right hand side, once we select an activity, as you can see, an activity is selected at 2 gigahertz, and you're seeing the corresponding FFT. As we move the activity to somewhere else, this is at 1950. This is at 1950 gigahertz, and you can see it's detecting signals, as you can see from the 3 spikes. This is typically the cell phone type signature that you're seeing on the FFT screen. There's a 40 megahertz bandwidth, and once you have decided to record this activity, you press the red record button, and the recording begins. And you also have to enter a file name, session name for the recording, and the recording starts. The recording can be stopped at any time, and multiple recording. During recording, a snapshot of FFT data is displayed. And as you will see, that we will stop the recording by pressing the stop button, and the system will go back to the configuration screen for the next setup. This concludes the quick and simple demonstration of the RFVision-1 system. What we haven't really discussed here is that it is a transceiver system, so you can also use it for transmit, for both receive and transmit, and for arbitrary waveform generation, RF test, either creating an RF output of pre-recorded data or computer generated data. So thank you very much. Thank you for watching this quick demonstration. If you need more information, please contact sales@dita.com.